Hello world, welcome back to another CTFlearn challenge video. In this video, we'll be walking through the forensics challenge, Brute Force is Fun. Let's get into it. You'll need brute force to solve this. Knowing Python should help too. Oh, and base64 encryption of course. Find the flag. If you download the file that they give you, you'll get this legotroopers.jpg image. Don't worry about this brute.py script, we'll get to that later. But if we open up that legotroopers.jpg image, we can actually see that it's just a bunch of Lego stormtroopers, just as the file name suggests it is. That being said, we'll close that. And what we're going to do is run binwalk on our Lego Troopers JPG file. And you can see there's a bunch of zip archive data. Well, cool thing about zip archives is that when they're embedded within inside of other files, you can actually just rename the extension or treat the main file as any other kind of archive file. It doesn't matter. It ignores that extra data. So we can just go ahead and run unzip on that Lego Troopers image, and we can see right away that there's some kind of flag.zip that requires a password. Well, we don't have the password, so we'll just press enter, and you're going to notice that it's creating a bunch of folders. Now, these folders that it's creating obviously don't require a password, as it's able to create and inflate them from the zip archive, or from the image in this case. So we'll let that run, and I'll skip to when it finishes. Once that's finished, you'll notice that there is a new folders directory right here, and we're going to actually navigate inside that folders directory. And you're going to notice all the different folders that it extracted from our zip file, or JPEG file. Well, it's going to take a long time to look through all these, and the hint we need to get the password is located somewhere within these folders. So we're just going to do a recursive grep for flag and see if that comes back with anything. Our grep command has finished, and we can see that there are two files that came back with a hint for us that says the password is CTFlag ********, where asterisk is a number. Okay, so this is where the brute force comes in. So our password for that flag.zip file is going to be CTFlag and then some sort of 5-digit number. Well, that should be easy for us to brute force. We just need to write a little script for it. And that's where my brute py script comes into play. So I already actually have that open right here. So we'll go ahead and walk through what I did here. I'm not going to code it from scratch because it's a pretty simple program to understand. Basically, we use the zip file module for Python and also the zlib. You don't really need the zlib, and you'll see why here in a second. But what we do is we open up the zip file, and remember, files that have zip files embedded inside them can just be opened up as normal archives, and we open that up as a variable z. So z represents our zip file. And then we loop from 0 to 100,000. And that's because our password can be anywhere from 5 zeros to 5 nines, or 00000 to 99,999. Then we're going to use the try except here to actually try each password. So we're going to set our password equal to CTFlag, and what this does right here is actually pad our number with extra zeros if it doesn't meet whatever length is specified on the right side of this colon right here. And then I, of course, is our number here. So if our number is 0, it'll add 4 extra zeros to the left side of our number. And then extract all attempts to extract the zip file itself, and we set the password equal to password.encode because we have to send the password as a byte string rather than a literal string to the extract all function. And then here I just print the password because it's interesting to know which password actually worked with the zip file. Now you could just do a catch all except block here, but I didn't do that because I thought this would be more intuitive. That way you can see what actual errors show up if you tried to execute this and a bad password is submitted to the zip file. So you get a runtime error, a zlib error, and a zip file bad zip file error. And that's why I had to import zlib. That way I have access to this error in order to check it in this except block. And then we just continue. You could also do pass there if this exception hits because we don't actually want it to quit executing the code if it errors. And that's how we're abusing the try except block here in Python because we're using the errors to determine whether it's a bad password or not. That being said, let's go ahead and run it. And this will take a while to run. So I'll cut to the part of this video where it finishes executing. Our code is finished executing, and we can see that our password ended up being CTFlag 48625. So our brute force part of the password ended up being 48,625. We'll minimize that, and we'll clear this, and we'll go up one directory, and we'll do ls, and you can see that we have a flag.zip file right here. If we try to unzip that flag.zip file, we can see that we get a flag.txt file. It actually had the password cached after it tried it against the zip file when it tried unzipping it in our brute force script. So we'll do ls again. We'll cat out the flag. And we can see that it's a base64 encoded string. Well, we know what to do with that. We'll cat our flag.txt into base64 tag D to decode that base64 string. And we get our flag. May the brute force be with you. We'll copy that, paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.